So hello everyone, my name is Oceane Albert. I'm a postdoctoral fellow at McGill University in the Department of Pharmacology and Therapeutics. And in the Robaire and Hales lab, we're interested in developing new generation plasticizers. The reason behind this project is that across the past few decades, a number of environmental pollutants have been shown to display adverse effects on the human reproductive function. Among those are pesticides, insecticides, brominated flame retardants, and also plasticizers. Now, the most commonly used and heavily produced plasticizer in the world right now is called DEHP. It is present in numerous everyday products. You find it in paint, in toys, cosmetics, medical tubing. And because it's not covalently bound to its supports, DEHP leaches to the environment over time, and we were all exposed to its potential adverse effects. So what we wanted to do was to find a responsible replacement for DEHP, a molecule that would be a good plasticizer, but also innocuous for the reproductive function. For that purpose, we undertook a four-step approach. The first step was to collaborate with the McGill University Department of Chemical Engineering to come up with a list of potential candidates that would be good plasticizers, would leach as little as possible to the environment, and would be also biodegradable. Now, they came up with a list of 20 potential candidates that we decided in the second step to screen in vitro. So on 9 different immortalized cell lines, we decided to look for toxicity of these products, and we found out that 2 compounds had the most interesting innocuous profiles, BDB and DOS. So we took these 2 compounds to a third step of the study, which is in vivo acute toxicity study. So we wanted to make sure that these 2 compounds would not produce any overt toxicity in an animal model. So we exposed adult male rats, and after looking at numerous endpoints, we found out that neither BDB or DOS produced toxicity in these animals. Now, one of the important facts in the literature is that we're particularly sensitive to these molecules during fetal life. So we decided to do a targeted in vivo exposure in an animal model. So we exposed pregnant dams to BDB and DOS, and also to DEHP, the compound we were trying to replace. And we looked at the effects on the offspring. Now, we followed the male rats at several steps throughout their lives, when they were little pups, through puberty, and also when they were adults, looking at phenotypes that we knew were altered after exposure to DEHP. So we looked at reproductive organ weights, hormonal production, testicular histology. We looked also more specifically during development of the pups. We monitored puberty, and we also looked at sperm quality at adult age. And what we found out was that while DEHP was producing some adverse effects that had been described before, our 2 candidate plasticizers, BDB and DOS, did not produce such effects, which is a very promising step into trying to demonstrate that it would be safe for replacements. And now what we're trying to do is to find out the mechanisms of action of these molecules compared to those of DEHP by looking at gene expression in the testes.